Okay, cool. So this session will be about threat mapping, which actually isn't really defined right now. So this is about marrying threat modeling together with wardley mapping. So that's the idea. So I came up with this idea after reading an article by Dave von Stein. So he used some wardley mapping for optimizing the threat modeling strategy. And I thought that is actually a pretty cool idea. So like, if we can make threat modeling output as a map, not just a diagram, then we can maybe come up with some strategic security decisions, or we can observe common practices or simply take better decisions than we do. So the idea is that we use this session more of a discussion on what ideas do we have, how to do it, and if someone has experimented with this before, or maybe they just find some better solutions for the problems that I'll show you. So if you want to jump in and ask some questions, or simply write in a chat, I'm more than happy to have this discussion, more just than having a presentation. So let's start with the really basics of threat modeling. These are just the questions from the current threat modeling manifesto. It more or less summarizes of what we expect from threat modeling. So we expect to answer the questions: what are we working on, what can go wrong, what are we going to do about it, and have we done a good enough job. But in the practice, then we have tools to execute the answering of these questions, right? We have threat modeling methodologies. And most of these methodologies, they are executing the answers of these questions into very common things. So usually a lot of threat modeling methodologies will create a diagram to talk about what are we working on, right? It could be a story, it could be a list of functions, but we usually end up with a diagram, right? Then what can go wrong? This is usually a list of threats. Sometimes they are attached to the elements in the system, attached to the elements on the diagram. But generally, this is a list of threats. And then what are we going to do about it? This is mostly an action, a recommendation, mitigation strategy, mitigation action, right? And this is usually connected with particular threats. And well, if we did a good enough job, this is more or less repeating the process one more time. So what happens is that we have this representation of the system. We make a list of threats. Then for some of these threats, we assign some actions, because some of them we just deprioritize and we don't care about them. And then we repeat because we just need to care about less threats than before, right? So that's more or less what we do with threat modeling. And we also expect from these threat modeling methodologies to serve some purpose and to have some actionable output. So in order to have actionable output, we want to have this registry of threats. We want to have a kind of document or a list or a table. Sometimes this is in a tool, in a CI/CD tool, for example, in Jira, or there are some custom tools, products to actually make lists of threats and log them and action the output, right? We also expect clear action, granularity of those threats. So that we don't end up in very generic threats, like just five stride threads, right? Sorry, 6 stride threads, or we expect some granularity. So we want to have a lot of threads in that table so that we can do something about them, right? And in that table, probably we have some other columns. We want to assign some priority, scope of a particular product or an element of the system, right? We can assign risk, potential risk to the potential threat, right? And then we can have responsible people for that. We want to have some definition of done. So if we assign an action to mitigate a threat, we want to have someone being responsible for that, and we want to define if that threat was actioned or not, right? Some measurements of success. And then comes like a lot of automation, statistics, common threads, because this happens a lot. So common components share the same threads, right? If we have 10 systems and each of them consumes some, I don't know, AWS S3 buckets, they share common threads. So it's good to stack the base thread models and apply just the previous actions that we designed for very similar products, right? The question that I'm going to ask is, is this process biased? Some time ago, I read this article that people are more likely to consider solutions to add features rather than remove them. And this was based on some idea of log bricks. The question asked to the people that took part in this experiment was how to fix this, let's call it a building, right? How to make it more stable. And most of the people, they added few new bricks, few new pillars, instead of just taking this one and removing it, right? The question is, don't we do the same with threat modeling? So let's say we have this representation of the system. We identify some threats, and then for those threats, we try to add control mechanisms, security mechanisms, some actions that will mitigate those threats. Instead of doing something that threat modeling was designed for. I mean, threat modeling was designed to change the design of the system in order to avoid certain threats, not just to patch them. So the question is the current threat modeling methodology biased towards like good old patching? Because if we have some diagram of the system, we log some threads that are attached to some flows or to some elements of the system. And then the natural way of processing this output from the threat modeling session is just assigning actions, assigning recommendations to each of those threads, thinking about them individually, not as a whole, or simply patching those small issues, because in the end, a threat is a potential risk, potential vulnerability. If in the process after the threat modeling we just run a pen test session or a source code review to actually verify if those threats apply to the system, for some of these threats we'll find vulnerabilities and we'll patch them, right? So assigning actions to each of these threats individually is just good old patching, right? The question is, do we need something else? For example, if we redesign the system and, for example, we don't use a web application and a server, rather just use some serverless components and a database in the cloud as a service, maybe we'll just not happen to have those threats in our system, right? So more or less, this is the question. So I was thinking about it. I didn't have much time since that article from Dave came out just last month. Like how to drop all assumptions about what we have currently in threat modeling and try to redesign it to consume some knowledge that we already have from wardley mapping. So I asked myself a question like, what does threat modeling bring to the table? And what we have is representation, so a list of components, usually a diagram, and we add, during the threat modeling session, we add information, information about threat actors, about the threats themselves. Sometimes we add trust boundaries, and in some threat modeling methodologies, we add attack vectors. So we have this representation to get an understanding of the whole security situation. And then for each of those elements in the threat information, we usually add some action, some recommendation. So if it is a threat actor, we try to block this threat actor, right? If it's a threat, we try to mitigate it or avoid it. If it is a trust boundary, maybe if we do something about it, this will be probably moving the trust boundary or moving other elements out of or in the trust boundary. If it is an attack vector, again, mitigate. So here comes another question: how to marry threat modeling with wardley mapping? So what we have in the current threat modeling toolset, this is this thread information that we add to the existing UML diagrams of the systems. What we just need to add more are the axes. to make it a map, right? Just as in standard wardley mapping scenario. The question is how we design the axis. So in the current view, we have the system. We have a diagram. This is without the axis now. We have a standard diagram, UML one. We log in some threads, let's say spoofing the information, tampering the information between the user and the API in a man-in-the-middle attack. So here is the story is that the user has a web application front-end to consume. It allows the user to send requests to the API. The API is hosted at server, and the server connects to the database, right? And the developer pushes new versions of the application to the server. So then we can have a man in the middle there. We can also have some issues in the API, access control issue, right? Standard stuff. So then the next step that we do after the threat modeling session, we try to come up with some actions. What can we do about those threats? And then we log in, for example, change the SSL configuration or make sure that it follows our SSL security guideline, right? We can design some test cases for the access control issues in the API. Or some control mechanisms. So the question is, if we introduce the axis, without introducing the axis, we don't see that we might have actually changed the whole system within this view of those axes. For example, introducing those two mechanisms, changing the configuration and adding test cases, maybe within the new axis, we moved the API component a little bit to the right. So we want to design the axis in a way that it serves a purpose, right? Another example is that we also don't see that that if we introduced access to the to this diagram, some threats, for example, that apply to the server, could be mitigated, remediated with multiple actions, right? One of these actions could be for the web server based threads could be patch the server, right? Or change the server configuration. But the one of the expected actions in the system could be also changing the whole infrastructure in order to use more evolutionary services. For example, instead of using a web application front-end and an API hosted on a server, maybe let's get rid of the server at all and just use Lambda function as a service, right? And a DynamoDB instead of hosting our own database in our own local infrastructure. And then if we introduce those access, maybe this will again move the whole picture a little bit to the right. So this is more what we expect from a secure system. What we also don't have without the access is some aggregation. So here is maybe not a perfect representation of aggregation, but if we did a lot of those threat models, maybe we could observe that if we use infrastructure that is more to the left or more a different infrastructure, let's say in this case without the access yet, most of the issues that we find or more of the exploits or more of the compromises happen to be here on the server. And then when we introduce the access, we may find out that the server component lies a little bit more to the left, because if we used, for example, Lambda functions, the server component wouldn't be vulnerable at all, and the exploits, the issues in the Lambda function will happen much less frequently than when it happens in the API, right? So we can't aggregate without this information on the access. So the hypothesis is that security strategic decisions require changing the design and not just placing those recommendations, actions on top of a threat. So we want to, out of threat modeling session, we expect to take more strategic decisions in security, not just adding new patches, right? And we want to make sure that our x-axis allow us to do it. So let's consider this simple diagram with a very simple threat modeling session, right? We have an attacker, so this is a threat actor, and an Apache HTTP server, and the threat, in this case an attack vector, is that the attacker exploits a remote code execution via a known CVE in the Apache server. And we could have 3 types of actions. For example, action number 1 is just patch the CVE today, right? Or once per month, introduce a policy to patch once per month. Then another good solution to this problem is that we could implement a vulnerability assessment tool. And this tool will continuously scan our service and set alerts when the Apache server is vulnerable to a known vulnerability, right? And another solution that is also good, probably the best, is automate the whole operating system image update via some CI/CD pipelines. And in this case, the software is much more mature in the context of the security. So I expect that these 3 actions will, on our new axis within the threat mapping, will behave somehow like on this image. So we have this patch today more on the left, and we have automating OS image updates on the right. So what I want to achieve basically is to prioritize better solutions. I call in this presentation, I usually call them strategic security decisions. So for example, if we are talking about input validation, about SQL injections, we could use some ad hoc input validation, right? Or we can do a strategic decision to use centralized validation mechanism, right? Typecasting. Again, ad hoc patching policy versus more strategic, predefined secure images. I think the previous session was on some images in the Kubernetes, within the Kubernetes images, right? And continuous scanning and updates, right? Manual pen test or mechanism to search for excessive files in web root directory, which is a common threat web applications. Then more strategic solution would be to introduce predefined routes to the API with allow list approach. So there is no way that there are any excessive files in web root directory, right? And the last one, like manual source code reviews versus tools that allow to do it continuously, right? Software composition analysis tools. So ideally, we want to change our systems, so potentially moving an element from left to right, and we want to introduce the axis that will be better in the context of security, right? So we know that we want to have the x-axis that says the more to the right, the better the strategy was this decision in the context of security, right? The software is much more mature in the context of security. But we haven't decided yet that we want to anchor the elements. Some of the ideas that I had, I think even from Denis, was that maybe just log the threads on the map. So then we will have a thread potentially linked to an action, and maybe it will mean something that this thread is more to the left or more to the right, or up or down, right? And then maybe it's not such a bad decision, because then we could find some threads that have an action that doesn't change a lot in the context of security, but for some threads, this action will move the whole situation more to the right. So maybe we can anchor the elements, or maybe we can anchor the threads. This will come later. So why? Well, let's imagine we have this practice that sounds pretty good, right? A lot of companies are doing that. Solid threat modeling. Then the threat modeling is also a scope for pen testing. So all of the threats logged during the threat modeling session are validated during a pen testing session, and then risk mitigation. The problem is that I've been trying that so many times, and especially for like legacy monolith applications or old technologies such as Java applets or PHP applications, changing the whole architecture of the solution is not possible. So in these cases, you just end up with patching the existing issues, and spending time on threat modeling doesn't really change the security a lot, because you could as well invest that time into pen testing or source code reviews. So the next question is, what should the axes be, right? In the standard wardley maps, the axes are value chain, visibility, and the evolution. The question is, should we stay with these axes when we talk about security, when we do threat mapping? So this is a fragment from Dave's article using wardley maps for optimizing the threat modeling strategy. And he stayed with the evolution axis as within standard wardley maps. And it allows pretty good output, right? And he introduced some ideas to reduce bias or to use reduce liability. So these are the movements on this map, which is also a pretty good idea why we should do threat modeling with maps, so that we can move, so that we could log movement, right? If we just skip a few slides. If we introduce these changes, we change the system. So we should log somehow the movement. If we just put the recommendation just near the threat, we don't log the movement. So we don't see how we increase the security of the solution. Okay, so let's get back to this one. So if we stayed with the evolution on the x-axis, what does it mean in the context of security? The actual evolution of the solution, so the business context, commoditization, that's pretty good answer. I mean, you have custom build API, or you could have standard like an API as a service, or you could have Lambda function, right? So these are 3 steps within the evolution axis. The next idea for an x-axis would be easiness of applying security mechanisms. For example, for a very custom built solution that is written in technology from 20 years ago, think Oracle, PL/SQL application, or some PHP applications, frameworks for these technologies are not updated with the current security knowledge. So it is much easier to apply security mechanisms to new technology stacks that usually corresponds to using more cloud, more serverless solutions, right? The next idea for the next axis would be risk. And then if we log risk on the x-axis, then we are probably anchoring the threats, not the elements. And the same with the risk visibility. If we put risk visibility on the x-axis, potentially we are talking about threats being on the map, not the actual system. And it has some consequences. For example, we can't easily reuse the UML diagrams created already by the system owners that serve the business purpose for the system. Okay, so we have some more ideas. Dennis mentioned that if we map the threats for the evolution axis, we can use threat agents. So who is the attacker, exploitability, detectability, assets, or business impact, or together all of the above that simply corresponds to risk. And I actually tried applying these ideas. So I tried to map a few solutions using risk and exploitability. Usually, I think one time I used exploitability of the issues. The thing is that, again, you end up with threats being anchored, and if you anchor threats, you are not changing the actual solution. You're just you're trying to action the threats, and I have a problem that this output is not really that actionable, that we could use something else. And Dave also had an idea to his points were to define the user on top. So that's And that's a pretty good idea, just to put the user of the solution on the top. You could have users, you could have developers also as the user of the system, because they consume the CI/CD pipeline and change the system, administrators, etc. And using the y-axis for something that makes sense to that user. So I took an example Google Cloud Platform session that I did recently, threat modeling for a typical application hosted in GCP. And I tried to anchor the threats and align them on the x-axis with the exploitability measure. So I simply ended up with deleting all of the components here, because moving the threads also changed the connections between the systems. Well, the connections stayed the same, but it was moved on the diagram, so the diagram didn't make much sense after all, after changing the position of the threads and position of the elements that were attached to these threads. But generally, well, yes, you end up with a map of threads. The question is, what do you do later? Like how to log the movement? What kind of actions do you need to do to move these threads more to the right? Okay, so the pros and cons of this is that if you use threads as anchors, the key elements on the map would be threads, then you can easily prioritize issues. Because if you align those threads within the exploitability or generally risk value, then you can easily take groups and put some priorities based on the position on the map, which is cool. But at the same time, you get unreadable diagrams, and movement of threads doesn't mean a lot to the people that are responsible for this system. So if you tell them that you should move that API to the cloud, they will understand it. But if you talk about some threat being and exploiting an access control issue and moving that a little bit to the right, it is totally different language. So my hypothesis is that to make a better discussion, we would rather anchor system elements, not the threads. So I had a few more ideas about how to do it, and came up with these axes. That on the y-axis you have visibility, but in the context of the attack surface. So on the top you've got things that are easily visible for the user and for the attacker. You could easily start compromising public networks or web application frontends or APIs, but to get to the databases, servers, and administrative networks, this is less visible. So this will be aligned more on the top, and the less visible components will be aligned a little bit to the down, right? And then the x-axis could be evolution, but in the context of security mechanisms. So I started with old technology on the left, with the new technology on the right, which is still the evolution in the wardley context. So we can have a monolith application that is together front end with backend, etc. Then we can have custom API, more to the right, API as a service, more to the right, serverless. When we talk about databases, on the left, locally hosted databases, the actions that are attached to the threads within the locally hosted databases, that will be also less strategic, right? Like manual pen tests, on-prem VA tool. This is usually also very costly to actually secure all of those locally hosted assets, right? Then cloud-hosted databases, probably cloud VA tools are better automatized, yeah. So like the VA tools that you can apply to the cloud have a better visibility, because for example, in particular cloud system, you can easily list all of the assets that are in this organization, right? And then if you have databases as a service, you solve all of these issues without actually running the VA tools or manual pen test, because you can just define the secure defaults configuration. So some baselines that those databases should apply within the privileges metrics or within exposure to the internet. So that's the idea. What can we do about it when we do it this way? So the possible use cases of thread mapping. First of all, aggregation that I mentioned. If we map the whole system within the Yaxis, maybe we'll find out that the solutions on the left share more threads that are more exploitable, and those that are on the right, they have less threads, they are less likely to be exploited. So in this case, there are also less actions that are needed to secure it. So the less threads, the less actions. So this is practically it. If we have component A that is more to the left, 5 threads apply to this component. If we have the same component serving the same purpose that is more to the right, we have just 2 threads, so also less actions. One of my other ideas was to anchor the threads that, well, make the threads take some part of the map and do not move at all. So, and not link them to the components. So imagine in the beginning, in this picture was just the yellow thread, and you had decision to either use component A or to use component B. And in this case, if you use component A, you end up with being potentially exposed to the thread. And if you choose to use component B, you're not, because this thread ends here. So that's one of the ideas. Also, I don't know if this is the case, but potentially actions that mitigate threats more to the left on this axis will cost more. So to secure, let's say, locally hosted infrastructure, it takes more time and more effort and more money to make sure that they're regularly up to date and that all of the firewalls are configured properly. While if you use component B that is more, let's say, in the cloud, doing the very same actions is cheaper, right? Okay. The thing is that sometimes for existing architecture, for existing systems, it takes some effort and money to actually move from component A to component B that is more to the right. So in this case, you could have a discussion on like cost effectiveness of this change. Okay. So the key questions that I want to start with in this discussion is if the idea is to do threat modeling together with the Yaxis, what is the best way to do it? What do we do? What do we use as anchors? Do we anchor the elements or do we anchor the threats? What are the connections and what are the movements? So if we mark this movement, what does it mean on the axis? And this is actually the last question. What are the perfect axes? What axes make it good and strategic in the context of security? And this is all of the slides I have today, and I hope that someone will just jump in this discussion and we'll start coming up with new ideas. Let me see what's happening on the chat. Hello, anybody there?
Hey man, I'm here. This was an amazing presentation.
Thanks a lot.
I definitely missed a couple of bits and bobs because I had to jump, into another call. But I definitely have tons of questions. We definitely want to do a follow-up session next summit.
So, like, my plan for now is try to use some of these ideas for the friendly link sessions that I'm doing. Yeah. Try different axes, and maybe in a few weeks I will have some more results and more ideas on effectiveness of this technique.
Yeah. Actually, I think I can stop recording. Right?
Yep.
Cool.